So now in this video we will learn about the meshing of the Y-shaped bent pipe. After you have saved the geometry file in the design modeler, we will now move on to the meshing part of the Y-shaped bent pipe. So as we are moving to the meshing, so choose the meshing from this toolbox. So this is the meshing, drag it here and only release it in here, and this will be the tab for the meshing. And now right click on it and edit. It will start the ANSYS meshing software. You can also see in the workbench that it says starting meshing, and this is our ANSYS meshing. It is still loading the file. So this is our Y-shaped bent pipe in the ANSYS meshing. So similarly as before, I have written down the steps for this meshing as well. So these are the meshing steps. So the first step is to generate a meshing method of tetrahedron using patch conforming method. I hope you know what tetrahedron method is, what patch conforming means, if you have seen my previous videos. So I will still give one line description of these terms. So the tetrahedron method is just a particular tetrahedron shape that will be used in the mesh, and it can differ with various shapes. It can be hexahedral, it can be tetrahedron, it can be automatic, or whatever you can name it. And the patch conforming method, it basically means that the meshing must conform the geometry. It can be seen that while generating the mesh can change its shapes rather than the geometry. So the patch conforming method ensures that the meshing does not change the shape of the actual geometry, not even a bit. So this is what the terms means. So now we are moving onto the meshing. So right click on the mesh, go to insert and choose method. But first you always need to change the physics preference to CFD, as we are doing a CFD experiment. So go to the meshing, right click on the mesh, insert and method. For the geometry, select the whole body and apply, and choose the method as tetrahedrons and keep the patch conforming or algorithm, and now should generate. So if you look at the mesh, you see a very rough mesh. The elements and nodes are very big, very large. Alright, so as the mesh sizes are very large, we need to lessen the my bad I have to lessen the shapes, the sizes of the shape of these tetrahedrons. As you see, I have used tetrahedron method. That's why I'm seeing tetrahedrons. These are the only one face of tetrahedrons. If I cut through this pipe, you will see many pointy tetrahedron shapes. So whatever that is, now we will be choosing a body sizing that will make these shapes a little bit smaller. It is also a step number 2. Now generate a general body mesh of sizing of 0.008. So go to the meshing again, right click on the mesh, insert sizing, and as we are giving this sizing for the whole body, select the whole body this time as well and apply. And let's say element size is okay, and change this element size is 0.008, and you should be choosing hard for the. Alright, let's just change this press should be no. You should see a soft and hard option here. If you don't see it, change the capture curve to no, and you should see the behavior and change this behavior to hard. This behavior hard or behavior soft, what does it mean? It basically means the same thing as the patch conforming, but it mentions all the intrinsic shapes of the geometry. So the hard behavior, it will ensure that uh, the machine always maintain these sharp edges. The sharp edges will be maintained. All the curves have to be maintained. As you see, these are very highly bended. This body is highly bended. This body is fully rounded. But our shape that we are using for the mesh is not even close to round. So the meshing shapes should also generate this shape, this curve. So to capture the curve properly, we should use the hard behavior and generate. And if we look at the meshing, you see a much finer mesh. And now, as we have seen previously in the laminar pi flow or in the 90-degree bend flow, the edges that the flow matters is very important while you are doing a meshing. So as you know that this is the inlet, this no these two are the inlet, and this would be okay. You can change it anything. Let's say this is the inlet and these are the outlets. You can change it to any time, anywhere. You can change it in meshing, in design modeler, whatever you are, wherever you are. So let's say this surface here will be acting as our inlet, and the other two surfaces here will be acting as our outlet. So as we have seen the 90-degree bend pipe, the edges of the flow matters the most while meshing. So as our flow will be entering here and we will be outgoing from these parts, so these edges of these shapes are very important. So this edge, I should be able to select the edge. So this edge. So okay, so I will be generating the much finer than this whole body sizing on the edges, on the important edges. The important edge should be this edge, and this edge, and the edge here, edge here, and edge here. So these edges need to have a more finer mesh. So we're gonna be doing that. So right click on the mesh, insert, sizing, choose the edge option and choose this edge while pressing your keyboard, and at the control keyboard select this edge, this edge, this edge, this edge, and finally this edge. So I have selected all the important edges where the flow will be much different than the other pipes, the other section of the pipe. So apply it here, 6 edges, and keep an element number of divisions and give it 50. Yeah, 50 should be good. I have also written it down in the steps. Generate a mesh for the important flow edges with 50 divisions. So it should be okay. And also change here the capture curve to no, and now you will see the behavior here, and change it to hard, and now generate it. It will take some time. Now let's look at our meshing, and you can see a much finer meshing in here, alright. Well, I don't see a basic difference in the meshing here. It's the same mesh as here, but at these edges the meshes are perfect, but not at these edges. So let's give a separate edge size at this inlet and outlets. So let's choose another mesh, insert, sizing, and choose, as I'll be selecting edges, so this edge, control this edge and this edge, and apply. And let's say giving an element size, change it to number of divisions and change it to 50 again and generate it. Let's say if we get the final mesh in the inlet of the outlet, it basically don't change here, but I guess the mesh sizing is applied here, so it should be okay. Anyhow, now the last step in our meshing is to doing a name selection of all surfaces. So firstly, just zoom fit it and select this surface and go to name selection, create name selection, and give it a name of outlet 2 or outlet 1, you can say, and give this name as outlet 2, my bad, and give this surface a name of inlet and give this whole surface as wall. And select the whole body and give it a name selection of flow domain. So let's look at the name selection if it has been done or not. Yes, inlet, outlet 1, outlet 2, and the flow domain, the whole body. So this with this the meshing of the Y-shaped bend pipe is done. Our next video will be on the setup of this Y-shaped bend pipe.